Good day, everyone. My topic is all about programming control instructions or master control reset instructions. But before that, but before I discuss my topic, let's have an icebreaker. So, guess the picture below. So, the answer is control. Programming control instructions, also know also known as flow control statements, are essential elements in any programming language. They dictate the order in which statements and functions are executed in a program, allowing developers to implement logic that can make decisions, repeat tasks, and control the overflow of the program. These instructions are fundamental for creating complex and functional software applications, enabling to them to respond dynamically to different inputs and conditions. So the objective is, or the aims of topic is: state the purpose of program control instructions, describe the operation of master control reset instruction, and develop an elementary program stating its use. Describe the operation of jump instruction and the lever instruction. Explain the function of subroutines. Describe the immediate input and output instruction functions. Describe the forcing capability of the PLC. Describe safety considerations built on PLCs and program into the PLC installation. Explain the difference between standard and safety PLCs. Describe the function of the selectable time interrupt and fault routine files. Explain how the temporary instructions can be used to troubleshoot a program. The key point is logic execution. PLCs execute instructions to implement logical operations such as AND or NOT or XOR. These allow for decision making based on the input conditions, enabling to control of industrial processes with precision. Sequence control. Control instruction in PLCs manage the sequential execution of tasks in industrial processes. They enable the coordination of multiple operations, ensuring that each step occurs in the correct order and at the right time. Timer and counter functions. Utilize control instructions to implement timer and counter function, which are essential for the base control and event counting. Data handling includes instructions for data handling such as storing, retrieving, or manipulating data. These instructions facilitate data processes tasks with PLC programs, enabling data logging, data analysis, and communication with external systems. Communication protocols support various communication such as for interfering with internal device network systems. System control instructions are used to establish communication links, exchange data with remote devices, and implement protocols such as Modbus, Profibus, Ethernet, or IP or OPC. Fault detection and handling control instructions in PLC incorporate fault detection and handling mechanisms to identify and respond to abnormal conditions. These enable the implementation of error handling routines, diagnostic checks, and fault recovery procedures to maintain system reliability. So this is the how how the processor operates. The following graphics provide a review of how the processor operating cycle without program instruction is divided. This is the common program control instructions. Jump forward or backward to a corresponding label instructions. Then use the program control instruction. Jump to label JMP or LBL. Jump to label instruction. An output instruction that directs the processor to skip ranks or forward or backward. Label instructions. An input instruction that is target to jump instruction having the same level of number. Zone. A section of ladder logic. That is example of multiple jump instructions. So when the jump instruction rung is true, so the program skips from the rung containing the jump instructions to the rung containing the design label instructions. A program continues executing. The zone rungs between the jump instruction and the label instructions are not executed. The zone outputs remain in their last state. When the jump instruction rung is false, a program does not execute the jump instruction. The zone rungs will be executed. The zone outputs function normally. The condition of the jump instruction rung has no effect on rungs outside the zone. Jump to subroutine, or JSR or SBR. Subroutine, a program file that performs a specific task. A subroutine will interrupt the program scan based on the specified instruction. For LSC 500 processors, program file 32255 are designated for subroutines. Subroutines are used in the following situation: loading a receipt, performing a calculation, cleaning a vat, purging a system, emptying a tank, packaging and selling a carton. The following graphic represents subroutines in a processor operating cycle. So input scan to program scan to subroutine scan to output scan. This is a cycle. So jump to subroutine or JSR. An output instruction that directs the controller to jump to a targeted subroutine file. SBR. An input instruction that marks the beginning of subroutine. Return. An output instruction that marks the end of subroutine execution or end of the subroutine file. That is the JSR and the SBR subroutine. A subroutine that directs program execution to another subroutine. Master control reset instruction. An output instruction that, when used in pairs, defines program zones where all non-retentive outputs may be disabled at the same time for the same length of time. Rungs within the MCR zone are still scanned, but scan time is reduced due to the false state of non-retentive outputs. The true and false state MCR instructions are summarized in the following table. If the MCR rungs start, the zone is true. Turn on the on or off according to rung continuously zone did not exist. False. Turn off regardless of rung continuity. So the MCR is not a substitute for a hardwired master control relay that provides emergency stop capability. TOF timers will activate when placed inside of a false MCR zone. If an unmatched MCR instruction exists in the project, the end instruction is used to mark the end of the MCR zone. Okay? So, the temporary end instruction. An output instruction that controls the scanning operation of a processor. When the logic preceding this output instruction is true, the TND stops the processors from scanning the rest of the program file. Update the I/O. Resume scanning at rung 0 of the main program. If this instruction rung is false, the processor continues the scan until the next end instruction or the end statement. Suspend instruction. An output instruction that causes a processor to enter the suspend idle mode and store the suspend ID in a word status file. All outputs are de-energized. This instruction can be used identifying specific conditions, program debugging, and system troubleshooting. So this is the diagram of interpreting jump label and the jump instruction. Example of JSR and SBR and ret instruction. So in application, in industry, in factories and warehouse, conveyor belt systems are used for material handling. Control instructions are employed to start and stop, speed, slow down, and coordinate the movement of conveyor belts to transport materials efficiently. In chemical processing, the program control instructions are the one regulate variables such as temperature, pressure, flow rate, and composition. This ensures the safety, efficiency, and the consistency of production processes. In safety system, control instruction monitors safety sensors, implement emergency shutdown procedures, and activate safety mechanisms to prevent accident and hazards. So, let's have a class activity. Provide an overview of PLCs in their role in industrial automation. Explain the importance of programming control instruction for controlling industrial processes. Introduce the objects of activity the program challenge students will undertake. Conclusions. Programming control instructions form the backbone of automated system, facilitating the management and coordination of various industrial processes. Control instruction, including basic functions like timers, counters, and more advanced operations such as sequencing and communication protocols are crucial for ensuring efficient, reliable, and precise control of machinery and process. A comprehensive understanding of PLC instruction is essential for designing and maintaining robust automation systems. These instructions enable users to implement complex logic, respond to real-time inputs, and control outputs, ensuring the processes run smoothly and effectively. As technology advances, the integration and the performance in industrial automation, the functionality and complexity of control instructions continue to evolve, allowing for greater flexibility. In conclusion, program control instruction is a vital professional in automation industry. It enables development of efficient, scalable, and maintainable control system, ultimately leading to enhanced productivity, safety, and innovation in industrial operations. Thank you. That's all.